Okay, we're going to try this again. I got interrupted. Sorry about that. So we're going to start on problem 13. And in problem 13 up here is talking about 60 students. And I want to know what 70% is. It's saying that 70% of the 60 brought their lunch to school. But my question is asking for buying. So it's sort of like my have and have not questions. This is how many kids have brought their lunch, and this is how many that will buy. I take my 60, which is my total, 70%, and I get the 42 because I reduce it down first and then build it back and get 42. But that 42 is who has brought their lunch, like they have their lunch from home. But 18% of my students are actually buying, which is the question that is being asked. In problem number 14, it's looking at flavors of ice cream and which students like those flavors. These labels are blocked out. It says that I have 150 students. I want to check that by adding it up, and I do have 150 students. I put my 30 and my 150 in from here, and I'm looking for what percent when I calculate to 100. I first reduce it down and then build it back to get my 20% of chocolate chip. So 20% prefer chocolate chip ice cream. In problem number 15, it's asking me to compare 65 stamps. 20% of them are the Valentine stamps, and I want to know how many of them would be Valentine stamps if there are 20%. So I have part, I have total. Total number of stamps is 65. My percent is always over 100, so it's 20%. Again, I want to reduce this down, and when I reduce this down and make it low, I get 1 out of 5. Now I can build it back up, and I need to know how many 5s go into a 65. That is times 13. So 1 times 13 is 13. To answer this question, there are 13 stamps that are Valentine stamps out of the 65. On number 16, we're talking about mockingbirds that are in the nest, and I have 8 little birds. It says that 2 flew away, and I want to know the percent that remained. So as I do this ratio table, we're going to find out that my total birds that I have in the nest is 8. My percent is always over top of 100, and I want to know the remain. If 2 flew away, how many are still in the nest? Those are the ones that remained. So I can subtract now and say that 6 remained in the nest if 2 flew away, because 2 plus 6 is 8. So I'm going to put a 6 here and now calculate. But before I can do that, I need to reduce it down and find out what this number is reduced. It is 3 out of 4. And now build it back up to a percentage, so times 25, and I get 75. So 75% remained in the nest, while 25% flew away. Again, this is like a have and have not question. Flew away and stayed in the nest, or remained in the nest. So think about it like that. Now let's look at problem number 17. We're looking at percentages, and we want to know which one is not the same as. It's telling me that this is my percentage. All percentages are based on 100, and yes, I can have a decimal in there, so this is 60 and a little bit more percent, 60.5%, 60.5%. So in looking at this, if I just took away the decimal, I want to know which one are the same and which one is not. Right now, I see that A looks to be the same. If I took this out of 1,000, it's meaning to get this 0 on the end, I move the decimal back one place. Here was the decimal, I moved it back one place. So B would be the same. translating Dr. Pepper, percent to decimal, move it once, move it twice, I would take the 60.5 and move it once, move it twice, and I would have 0.605, which looks like C being my best answer. This is the same thing with Dr. Pepper, but it only moved it once. So D is what is not the same. Please pay close attention to words in your test on Tuesday, to what you have, what is have not, calculating both and seeing what's reasonable. Good luck on that test on Tuesday. I hope you have this for Monday and have clarified.